In this video, I'm going to talk about gluten. Once again, if you're not interested in the science of bread, you can skip ahead and the next video will be more practical. So gluten is a substance that forms from the protein in flour when it mixes with water. There are certain proteins that are involved. There are long chainy ones called glutenins and then shorter ones called gliadins. And when the flour and water get mixed together, these proteins bond with the water molecules and also with each other. They form gluten, which is this stretchy, elastic substance. And it's what gives bread dough the feeling and the behavior that we're familiar with. And it's what gives bread its final structure. So gluten is stretchy and flexible and also elastic. No one is really sure what the exact chemical structure of it is, but different proposals have been put forth through the years. I'll show a picture of one of them. You can see that it has places where the chain is folded or curled in a helix, and those would be places that make the molecule stretchy, but also elasticy. So first we're going to talk about what's going on when gluten forms. You may remember from your school days that protein is a chain of components called amino acids. So there are several different kinds of amino acids and they have the same basic structure, but then there's a group coming off each one and different amino acids have a different group. When you mix the flour and water together, all different kinds of bonds form. So these include bonds between the water molecules and the amino acids, and then they also include bonds between the amino acids. There are strong sulfur-sulfur bonds, and there are hydrogen bonds that form between nitrogen, hydrogen, or oxygen atoms, and then there are weaker electrostatic interactions. So among all these bonds, some are stronger than others, and then some of the bonds are aligned in the same direction. So they're basically working together to resist any force that's tugging on them. As you begin kneading dough, the weaker bonds might break, and that frees up the electrons of those bonds to form better bonds. So it's actually a good thing to have some breaking. And as you keep kneading, stronger and stronger bonds form that can resist the force of your kneading. And again, these bonds might align and work together, so you get them all running in the same direction and resisting the force of the kneading. And so this gluten network that develops becomes stronger and stronger, and this is what gives strength to dough and makes it tough and gives the ultimate structure to your bread. It helps the dough rise in a more controlled manner. So this begs the obvious question, what about no-knead dough? I wondered this for a long time, and it was finally explained to me that hydration is key to the bonds forming and the network of gluten forming. And when we knead dough, we're just speeding up the hydration process and helping the water molecules get in among the protein and bond and helping the weak bonds break and the stronger bonds form. But this process would still happen without kneading. It would just take longer. So you might notice that no-knead recipes, they often have a very long rising time. They're often a pretty wet dough, and they usually include a series of folding, which is a little bit of like stretching. So you're not kneading, but you are doing a little bit of work stretching the dough. And all of those factors combined result in the same effect that you get much faster by kneading dough, which is developing a strong network of bonds that is in the dough and resists the gas that's forming and helps the dough rise in a controlled manner.